right?
Looking very dapper.
You threw a cherry at.
Well,
What's in your hand? Guys, what is going on?
all right. My plan here, the next couple of classes. Today, we're going to do sections 3.1, 3.2, and 3.3. Next class. So today, we're going to do sections 3.1, 3.2, and 3.3. On Wednesday, we're going to do section 3.4. Friday, we're going to do the chapter 3 quiz. Next week, we'll take a day to kind of gather ourselves and get ready, and then the following class will take the test after that. So again, it's another like 2-lesson or 2-day unit. The good news is the things that we're doing here is pretty straightforward. Let's start with section 3.1. This whole chapter is about sequences and series. So I want to start with just some like notation and vocabulary to talk about what we mean by a sequence. So recall when we talk about a function, a function is some pairing of things from a domain over to some things in a range, right?
Yes.
And with function notation, we say like f of x equals like 2x plus 7, right? Where the x stuff is our independent variable and the y stuff, our f of x, is our dependent variable. Right? This all rings a bell. So a sequence is just a kind of function. But the difference between a sequence and a function in general is the set of values for the domain. So in a sequence, our domain is always going to be natural numbers. So positive whole numbers like 1, 2, 3, 4, 5, 6. No decimals, no negatives, no fractions. Positive whole numbers only. The range, though, could be any real number. That's fine. Now, instead of using x's for our domain, we're going to use the letter n. And instead of saying like f of n, we're going to use some other lowercase letter. And instead of saying f of x, we're going to have like a subscript n. So like the equivalent sequence version of this function f of x equals 2x plus 7 would be like a sub n equals 2x plus or 2n plus 7. Now, the independent variable has a name. We call that the term number. And the output, the range, has a name. We call that the term value. So, for example, if we write like a sub 3 is equal to 10, we'd say the third term of the sequence is 10. What's up, Nora?
So if you scroll up, it says domain in green. What's the IND and the DEP?
So that's independent and dependent. It's just me abbreviating what the variables are there.
Okay, thank you.
Sure. Is everybody okay with the vocabulary and the notations, really the difference between a function and a sequence? Very little difference, right? We're going to use a different notation. But the only real difference here is that the domain for a sequence is always the natural numbers are a subset of the natural numbers. Okay with that? All right, so let's look at some examples here. So let's say we have the sequence here. And one way we can describe a sequence is a list of values. So if these are like my a sub n's, how many terms do we see in this sequence? There's 5 numbers listed, so we have 5 terms. That's exactly right. So we can say like the first term is 1. The second term is 4. The third term is 9. The fourth term is 16. The fifth term is 25. Does everybody feel okay with the notation there? Now, because this type of sequence has just 5 terms, we could call this a finite sequence. Now, if I had the same sequence, but instead of ending at 25, it ended with ... what is that telling us? Yeah, it's an infinite, well, it's not continuous, but it's got an infinite sequence because there's infinitely many terms to that sequence because it's going to continue following whatever that pattern is forever. Ever and ever. What do you think? So far, so good? Easy peasy, right? So all we've done is just some vocab and talk about some names of stuff and symbols and no big deal. So for example, you might be asked, given the sequence b sub n equals 2 minus 1 over n, write the first 5 terms and the 50th term. So the first term is going to be b sub 1. So to get that, all I'm going to do is fill 1 in for n. To get the second term, we're just going to fill 2 in for n. To get the third term, we're going to fill 3 in for n. Oops. To get the fourth term, we're going to plug 4 in for n. To get the fifth term, we'll plug 5 in for n. And to get the 50th term, we're going to plug 50 in for n. But all we're doing is basically plugging numbers into a function, right? Super simple. Everybody agree? I mean, I did the arithmetic really fast in my head, and you might be impressed by that, but like, that's what calculators are for. You're never going to be denied a calculator, right? We're going to trust that we can all operate our calculator effectively. Oh, yeah. All right, so that's kind of the introduction to like what a sequence is and how to kind of use a formula to generate terms of a sequence or how to name the terms of a sequence. There are 2 main types of sequences that we'll talk about. The first one is called arithmetic, and the second one is called geometric. So that's going to be 3, 2, and 3, 3 is these 2 types of sequences. Yeah, looks like arithmetic, but we pronounce it arithmetic. Hey, dude, I got a stack for you here. Hold on a second. Don't go nowhere. It's somewhere in here. This stack? Yeah. All of this is yours, I think. That's fine. I didn't take attendance, so. I forgot. So I think we're all good. All right. So, again, we can write we can write a sequence a couple of different ways. We can describe it as a list of values. with a dot, dot, dot at the end or whatever. Or we can describe it with a formula. For an arithmetic sequence, we might describe that formula in two different ways. There's an explicit formula. That's this one. Oh, there was one in there that I shouldn't have given you. The rest of them were yours, though, right? The rest of them are yours, though? Okay. Double check that for me. I think so. Okay. Now, this is the one the textbook gives you. I would say you could even be more general. And we could write this guy where I is just any ith term of the sequence. So the 5th term or the 9th term or the 22nd term. And the other way that we can write a formula is as a recursive formula. So this guy is like this is like our nth term. This would be the previous term. D is called a common difference. And the same idea here, like nth term. This guy would be like the first term. This would be like the ith term. N would be like our term number. D is still that common difference. I would be like the ith term number. Is that okay? Okay. If we look at, say, this formula here, does that look familiar to you guys?
Yes.
Yeah, it should resemble this guy, our point slope equation for a line. So if we say instead of our function is n's comma a sub n's instead of x comma y's, so and we have the point 1 comma a sub 1, this becomes a sub n minus a sub 1 equals m times n minus 1. And if I add the a sub 1 over, boy, this looks almost identical to what we had before. And just here, instead of writing m, I wrote d. Guess what d is? Still a slope. Yeah, that common difference is a slope. So this is literally just a linear equation. So when I see arithmetic, I think linear function. So everything that we did last chapter, where we wrote equations for lines and stuff, can do all those same techniques here with arithmetics. You don't have to use the arithmetic formulas. You can just treat them like points and just write equations for lines and stuff that we're already pretty good at, right? Reasonably so. All right, let's just run through some examples. That's about the gist of it, though. All right, it says find the nth term and 50th term of the sequence. So first thing I'm going to do is identify the type of sequence I have, because ideally other stuff could get mixed up in here. So to check if it's arithmetic, I'm going to just check to see if the difference between the terms is a constant value, if it just stays the same. So not the difference between 2 and 11 is 9. The difference between 11 and 20 is 9. The difference between 20 and 29 is 9. Stayed constant the whole time. So what this tells me is that my constant difference is 9. Is everybody okay with that? Super easy, right? So then if I just take my formula and I fill in for the first term and my D, I can then like distribute the 9 through and combine some like terms, and I get 9n minus 7. So that's like my nth term here. And either of these two formulas technically would be fine. And then the 50th term would just be a sub 50. So 9 times 50 minus 7, which would be 443. What do you guys think on that? Pretty easy, right? Now, the nth term, this is the same thing as asking for the explicit formula. Those two mean the same thing. The textbook and the IB will use those two phrases interchangeably. Oh no! Yeah. Yeah. You guys, Nora's had enough. Okay? Save all of the rest of your teasings for tomorrow. I don't know, but we're at our limit for today. She's had enough things thrown at her and corrected and everything else. So. All right, so find a definition for an arithmetic sequence. Again, this is another way of just asking for that explicit formula. So I need to do this. It tells me the first term is 5, and the fifth term is 11, so I know a sub 1 is 5. And then a sub 5 is 11. Everybody's okay there? I'm going to really think about this as like the points 1, 5 and the point 5, 11. Everybody's okay there? So if I just kind of plug these in, I have 1 already there. 5 is going to go there. This 5 is going to go there, and this 11 is going to go there, and then I'm just going to solve that for D. So if I subtract the 5 over, I get 6. 5 minus 1 is 4. Divide by 4, and I get reduced 3 over 2 for D. So this is that guy, or if I distribute things through, is 7 over 2. Everybody's okay there? Or alternatively, you could have just thought about this as like a slope-intercept problem. So if D is M, I can just do rise over run. And if I do y equals mx plus b, I can say like 11 equals 3 over 2 times 5 plus b. And if I solve for b, I'm going to get negative 7 over 2 is b. So I'd have like y equals 3 over 2x minus, or I should say plus 7 over 2. Or if I want to rewrite that then in the language of a sequence, y is a sub n and x is n. But we see it's the same, we're doing the exact same thing. It's just like different language. It doesn't matter to me how you want to do it. If you want to treat everything as points and just do like your equations for line stuff that you already know how to do, totally fine. You're doing the exact same thing. So far so good. Okay. One thing that the IB is going to do all over the place in this section is try to create story problems to do out of this stuff. Their favorite type of story problems are going to be like financial related. So the idea here is simple interest equals arithmetic. Other types of interest or depreciation or growth or decay or anything else like that is going to be geometric. So the simple interest formula is that your account value is equal to principal plus the principal times the interest rate times time. So for example, let's say you deposit $1,200 into a account with 5% simple interest paid annually. How much is in your account after 5 years? And again, that's assuming there's no additional deposits or withdrawals or whatever. So we can just say that like A is equal to the initial investment times that initial investment multiplied by the interest rate as a decimal times the number of years. So it just, oops, easy peasy. So I have like $1,500. Is everybody okay with that idea? So this guy's kind of like my A sub 1. This, say A sub 0, I guess, really. This is kind of like my D, and that's kind of like my N. I really like N minus 0. So it's still like you can think about it as an arithmetic sequence, but like Y, it's like a algebra 1 story problem where you're just solving like linear equations and plugging stuff into a linear equation. Like, why overcomplicate it? Yeah, it's pretty straightforward. Probably the hardest thing they're going to ask you to do would be something like this. You know, given the sequence with u of 50 equals 6, u of 51 equals 11, and then u of 52 equals 16. Find u of 1. So again, should start by noticing that like this is arithmetic because the difference between the consecutive terms is constant. And then I can just say like, let's use u's, I guess. and we're just going to fill in things to solve for use of 1. So I'd say like 6 is equal to use of 1 plus 50 well, let's do 50. Let's use this one. Just because 51 minus 1 times 5 is going to be a lot easier to deal with than the other one. Not that I couldn't deal with it, but like, come on, who wants to deal with a 49 when you could deal with a 50? Word. So I get 250 there, and if I subtract it over, I get negative like 239 for use of 1. So don't look at the work in the textbook because their work for this problem is wrong. I stared at it for like 5 minutes, 5th period, going, what the heck did I do wrong? And then realized that, oh, the editor did something wrong because they didn't actually work through any of the example problems. They just read the words or something. Okay. That's the gist for arithmetic sequences. The next one is geometric. When we see geometric, you need to think exponential. So our explicit formula for this would be like a sub n equals a sub 1 times r to the n minus 1. Or even more generally, a sub n equals a sub I times r to the n minus I. Where you have some point I comma a sub I instead of 1 comma a sub 1. Okay. And then the recursive version of this is the previous term times r. And r this time is going to be just called the common ratio. When you hear ratio, you should think division, right? It's one term divided by its previous term should give you r. That's constant for all terms, then it's geometric. So that's the gist of things here. So let's just kind of do some examples. So let's say we have the sequence like this. The first thing I'd want to do before I decide try to write a formula for this is to decide if it's arithmetic or geometric. So when I see the alternating signs, immediately I know it's not going to be arithmetic because I can't add or subtract the same number and signs go positive, negative, positive, negative, positive. That's not going to happen. So I know it's probably geometric, but it can't be arithmetic. I notice that if I multiply by -4 each time, I get the next term that tells me that r is -4. So I can say then I have my first term times r to the n minus 1. Does that feel okay? Texty McTesterson, like let's chill it out on the cell phones there. Buzzy McBuzzers.
What is buzzing?
I mean, I heard a lot of buzzing. Does that feel okay? Let's suppose that we do the hardest version of this kind of situation where, like if I have that the 5th term is 1 and the 9th term is 243. Oh boy, that's maybe not the greatest idea. Hold on a second. 1, 2, 3, 4, 5. Let's make it the 10th term. And actually, let's flip those. Let's make the 10th term 1 and the 5th term 243. I know, Olivia, it'll be okay. All right. So what are we going to do here? Basically, I'm going to set up a system of equations to solve. So I'm going to think about each of these as like an n comma u sub n. And plug them in. So I'd have like 1 equals a sub 1 times r to the 10 minus 1. And then I'd have 243 is equal to a sub 1 times r to the 5 minus 1. And that's going to create like a system of two equations, a and b. I'm going to solve that system using like substitution or elimination. Now, let's contrast this to what we did in the last chapter where our variables that we're trying to solve for were being added or subtracted. Here our variables are being multiplied. So I'm going to do elimination here to solve this system, but I'm going to eliminate my variables because my variables are going to be multiplied. I need to do division. I want to be a little bit careful here to make my life simpler, is I want the equation with the biggest exponent to be the numerator of my division problem. It still works the other way, but it like makes things uglier than it needs to be. So I'd have like 1 over 243 equals a sub 1 times r to the 9th over a sub 1 times r to the 4th. Well, the a sub 1s are going to cancel there. There's my elimination happening. R to the 9th divided by r to the 4th is 5, r to the 5th. And then I'll just do like the 5th root to both sides. Because it's an odd root, I don't have to worry about the plus or minuses. The 5th root of 1 over 243 is 1/3. And now that I have r, I can plug that into either my first or second equation. It doesn't matter which. So to solve for a1, I'm just going to multiply both sides by 3 to the 9th. And I'm just going to refuse to write that out any further because yuckarooskies, that's a gross looking number. But there's the idea. So I want to point out to you that any of these problems where you're given like 2 terms of a sequence and asked to write the formula, your calculator can do this. Okay. So the way that I have my calculator do this, if you want to take out your calculator and follow along with me, I'll happily show you how to do this. And again, on the IB exam, do they care about your shown work? Nope. So if they ask you to do this, could you just do it on your calculator and write down the answer? Yup. So I'm going to start by pressing the Stat button. From the Edit tab, I'm going to select the Edit option by pressing Enter. And then I'm going to clear out a space in L1 and L2. In L1, I'm going to type my values for n. So in this problem, that would have been 10 and then 5. And in L2, I'm going to enter the corresponding a sub n values. For this problem, that would be 1 and then 243. Everybody's okay? Okay, I'm going to exit out of here now. I'm going to go back to the Stat button. This time I'm going to go over to Calc. And because this is a geometric sequence that I'm writing the problem for, it would have told me in the directions. I'm going to go down and pick exponential reg. I'm going to do that on L1 and L2. And then just hit calculate. So there's tells me my A, that's my first term. Tells me my B, that's my value for R. And I'm done. Can I do the same thing for arithmetic? Yes, but instead of picking exponential reg, what would I have to pick? Lin reg. Everybody cool with that?
Mine
Eva?
doesn't look like that. Just hoping the Y was AX.
That's fine. You don't need the R's.
Oh, okay.
The R's don't. They're just for the. We talked about it before with the. That's like the R from last semester.
We're not gonna need to know the test, right?
Nope. Because if all you're using is 2 points, the R's are always going to be 1. Because one line fits perfectly through 1 point, regardless of, or 2 points, right? You're always going to fit a perfect line through 2 points. The other thing that they're going to do here with the geometric is if we have compound interest, that's not how you spell compound, or population, growth, some kind of like decay, maybe radioactive decay or population decay, or like depreciation, like some asset is depreciating. All of these things are going to be geometric sequence problems. So all of those kinds of problems could be geometric. If it's compound interest, this is the only one that like we need like a formal formula to deal with. So A is like our account value at time t. P is the principal. That's the initial investment. R is your interest rate as a decimal. N is the number of compounds per year. And then T is time. Typically that's in years. Okay, so essentially this is our formula. So let's say we have you invest $15,000 in an account earning 6% annual interest compounded monthly. How much is the account worth in 20 years? So we'll just say, okay, this is my principal. That's my interest rate. Compounded monthly, that's my N is 12. 20 is my T. So A is 15,000 times 1 plus 0.06 over 12 to the 12 times 20. So it just goes into my calculator. You guys kind of remember doing these before in Algebra 2 or pre-calc maybe even. So $49,653.07. Hey, why didn't I round that to 3 sig figs? It's money, right? We round to the penny for money. Everybody's cool? Money. What if I ask how much interest was earned? Well, how much of that 49,000 was our initial investment? 15,000, right? So everything else must be from the interest. So that's just going to be, yeah. So $34,653.07. Super simple, right? Just got to know how to read the problem. What if instead we ask, you have $1,000 to invest in an account that compounds quarterly. What interest rate is needed to double your money after 10 years? So again, compound interest formula. That's my principal. That's my N. Double is my A. T is my time. And R is what we're going to be searching for. So we have 2,000 equals 1,000 times 1 plus R over 4 to the 4 times 10. We're just going to be solving this equation now for R. To do that, we'll divide both sides by 1,000. And then how am I going to get rid of this guy? Nope. I'm going to do the 40th root. Now, technically speaking, because that's an even root, I should get a plus or minus. But what do I know has to happen here? It's got to be positive, right? Because what do I know about R? Interest rate has to be, well, it has to be positive, right? Nobody's going to invest in a bank account that pays you negative interest. It's going to take money from you every year. It's a pretty bad deal. You might find an investment that does that, but not on purpose. All right, so to solve then, we'll just subtract 1 over and then multiply both sides by 4. And that ought to do us. How do I do a 40th root? I just do it as 1 to the 1 over 40 power on my calculator. Oops, that's supposed to be a plus there, not a minus, you goof. I wrote it down right. There we go. So I get about 7%. What do you guys think? This should be fairly straightforward stuff. Like you do basically all these things in Algebra 2. Maybe you call it a different name or whatever, but like the sequence side of it's pretty easy. The harder part is the series stuff. Will go a little bit slower there because that's stuff that you haven't really seen before, although it's still just kind of basically using formulas. And even like, I'll show you how to use your calculator. You can do most of it even without the formulas, just by using your calculator, which is pretty cool too. But that's the gist of it. So you guys should, for Sunday's problem set, you guys are going to have sections 3.1, 3.2, and 3.3. It's a lot of problems, but they're all relatively quick. You know, like we crank through these things like a minute a problem, so they're not so bad. Some of them are probably less than a minute a problem. But that's Sunday is those 3. The following Sunday you'll have the 3, 4, problem set, but I won't have that due this Sunday because, well, those 3 sections are enough, I think. Again, what's happening on Friday? Quiz on 3.1, 3.2, 3.3. I think I have the quiz description already up in here. So again, you should be able to identify if a sequence is arithmetic, geometric, or neither. You should be able to use arithmetic sequences to do currency exchange. So it'll give you like a rate of exchange. That's basically your D, and you just set it up otherwise. Be able to find the nth term of a sequence, either arithmetic or geometric, and use that to compute a specified value. Right, so like we've done before, find the nth term and then find the 50th term or the 100th term or the 10,000th term or whatever. It's pretty straightforward. There's really not a whole lot of different ways we can ask questions here. But we'll deal with, if you do some of the homework before next time, I'll answer questions, if you have any, from doing the homework. And not just copying the answers out of the back of the book onto a sheet of paper and putting in the OneNote. Not that anybody's doing that. All right. That's enough for me. You guys feel okay with what we did today? I know I went quick through stuff, but should have been pretty easy, right? Felt okay?